Of Allah, who is the most gracious and the most merciful. The computer have becoming so fast, and we use it for different tasks like running the whole and the entire internet, the graphical live, and the interconnection of objects and communication between them, like sending and receiving, for different things like the artificial intelligence, in which a machine can think like the human being and can work like human being, controlling of rockets and other space bodies for the security purposes and for other purposes too. And now I'm going to give you the map of computer science. Now I'm going to divide the computer science into three parts, like the theoretical computer, computer engineering, and applications. Computer science can be classified into many parts, but they are all the subparts and the carriers and areas inside these trees, like the theoretical, computer engineering, and applications. And maybe further after this you will see that. Whenever we come towards the theoretical computer, we come across a name called Alan Turing, the father of theorists of the computer, who for the first time gave the idea of the general purpose computer called Turing machine, which had a long tape, a head, and a state register. A tape as infinite type zeros and one, that was the instructions, the head with the read and write signals and symbols, and a state register that stored the state of a machine, and also a list of other instructions. But whenever we want to compare it with a modern computer, we come to a conclusion that it is a bit same to the Turing machine, like the RAM is a kind of tap, and the CPU, where all the processes in the instruction takes place, are being processed in the CPU. And also it will have additional hardware components like the sound, the SSDs, the CPU, the GPU, the FPGA, and other hardware components that will come. But basically the Turing machine give the idea of the general purpose computer for the first time. Anything that can be computable using Turing machine can also be computable using Land calculus, and which is the basis of all the research in the programming languages. And the computability theory made an attempt and tried to classify problems which isn't computable with a computer. And we come across the problems like from which it is the halting problem that can never be solved using the computer. It will run forever or stop running. That is, we can say that the recursion, the function call itself again and again, and the infinite iteration in a loop. And for the different complexities we we come across towards the concept like the algorithm. Algorithms is the set of instructions that uses to solve a particular problem, and algorithms are independent from any hardware in any other platform and from any other computer or programming languages. So they uses to identify and to find the different complexities of for different problems. And we can see now the problem, sorting problem, and the bubble sort, and on the other side the merge sort, and you can see it now. I'm going to crack the information theory that deals with the storing and communication of information, and that uses different techniques like compression and error correction. Compression is used for the reduction of bits for representing of particular information, and it is the example of reduction, the real life example. Encoding theory is also an example of information theory. In the cryptography, we come across another concept, cryptography, that the data is being encrypted inside the channel, and the mathematical problems to keep the data and the information locked from the outsiders. And we have also another theories like the automata theory, graph theory, computability, or computational geography, and other like logic. Computer engineering, the technical, important, and critical part of the computer science that deals with the designing of the computer, and we can say that best design, more jobs get done. And I'm going to give you the example of scheduler. The scheduler use the scheduling and priority techniques in order for the different tasks, in order to allocate the CPU for the different tasks. And we say that it is being simultaneously processed by the CPU, but they are scheduled in using the scheduler, and we will faster the work of CPU and the work of computer using different multiple cores or multiple processor, but it will make the job of the scheduler a bit difficult, but we will have the advantages of the speed. Now we jump to the computer architecture. Computer architecture, in which we say that the CPU, the general purpose or central processing unit, and the GPU, the graphic processing unit, that is for the graphic a circuit that uses for the graphics, and FGPA that uses that stands for field programmable gate arrays. It includes digital signal processing, bioinformatics, device controller, software defined radio, random logic, and many more are the uses of FPGA. On the top of these hardware we have many layers of software, and they're programmed by the programmers and using many different programming languages, and the compilers, the operating system, all come because of the combination of these three. So now we're going to crack some other topics. Software engineering, writing bundle of instructions telling the computer what to do, in which the program will translate its creative idea into a specific language and must be efficient and error-free, and so that it can run on a machine in a correct way. And we have a lot of best practices in order to improve it, and a different model, like you see the waterfall and agile model. Beside this, we have another concept like networking for the interconnection of two objects, the management of data, the performance, and the realistic graphics because of the computer. Coming towards the last part, in the important part, the interesting part of the computer science, that is application, where we can tell the computer and we can make the applications to solve the real world problem for the human being. And there's we come toward the optimization that is related to the Boolean satisfiability, where you come across where you can where to check, make an attempt to work out if the logical formula satisfied or not. Once it was considered impossible, but nowadays it is the umpteen number of problems being solved using the artificial intelligence. And artificial intelligence comes with the machine learning and other machine learning techniques like the supervised, unsupervised, and reinforcement. Natural language processing aimed to get computer to understand and communicate using human languages, and this uses another field called knowledge representation, in which words with similar meaning are clustered together, like the cake related to the food, and other matters and other words related to it. We come to Internet of Things, and another concept like hacking.
Machine learning algorithms have improved because of the large amount of data we give them. Big data looks at how to manage
hacking, that finds the weaknesses of a computer system and get advantages of it, and without being noticed. Now we come to computational science, virtual reality, augmented reality, telepresence, and robotics. These would all come in the area of applications And now at the end, I'm gonna say that I highly recommend this map of computer science for the newcomers to computer science. If somebody is new in computer science, if he for the first time make the map of computer science, he would be able to make his choice according to his choice, and it would be very easy for him. Now I'm going to show you the whole map of computer science. That's the whole map of computer science you can see in the screen now.